Okay, we'll continue with our third video on evaluating limits algebraically. And in this video particularly, we want to stress the properties of limits. And for the most part, limits behave in a very intuitive way. They behave the way we expect that they should behave. So for example, in problem number 37, we have the limit as x approaches c of f of x is 3. We don't know what the function is, and we don't know what c is, but we're just told that that limit is 3. And we're also told that the limit as x approaches c of g of x is 2. Then we're going to use that information to evaluate these four expressions, or these four limits below. Now the first one says the limit as x approaches c of 5 times g of x. And it's not important that you remember these, but this is called the constant multiple rule. And what it says is that the limit of a constant times a function is equal to the constant times the limit of the function. So let me write that out, but it's very simple. The limit of a constant, that's the 5, times a function, which is g of x, is equal to the constant times the limit of the function. And we know what limit as x approaches c of g of x is. That's given to us, and we know that that happens to be 2. And so we end up with 5 times 2, which is 10. Now you can look at this a number of ways. You can think of it as the constant comes out through the limit, or you multiply the constant times the limit of the function. Let's look at the next one. The next one we're going to call the sum and difference rule. So the limit of f of x plus g of x, the limit of the sum is going to be equal to the sum of the individual limits. So that would just be limit as x approaches c of f of x plus limit as x approaches c of g of x. And the first is 3 and the second is 2, so that just gives us a total of 5. Again, it works the way you would expect it to work. The third one, it's a product rule, which just says the limit of a product is equal to the product of the limits. So the limit as x approaches c of f of x times g of x is the limit as x approaches c of f of x times the limit as x approaches c of g of x. Again, f of x is the limit as x approaches c of f of x is 3. The limit as x approaches c of g of x is 2, and so we have 3 times 2, which is 6. The next one could be considered the quotient rule. The limit as x approaches c of f of x over g of x is the limit as x approaches c of f of x divided by the limit as x approaches c of g of x. The numerator again is 3, the denominator is 2, and so that gives us 3 halves. Okay, so you can try a similar thing with problem 38. I'll go on to 39. It's slightly different, but not bad. This is the idea of function composition that was talked about in the previous video. And I'll just restate that here. When you have function composition, the limit as x approaches c of f of g of x is going to be the f of x, or rather f of the limit as x approaches c of g of x. Put into words, what that means is we take the limit of the inside function and simply plug that into the outside function. So we don't do a second limit of the outside function. So for the first one, 39a, we have the limit as x approaches c of f of x to the third power. So all we're going to do is find the limit as x approaches c of the inside function f of x, that's 4. We plug that 4 into the outside function, which just says raise it to the third power, and that gives us 64. Second, b, limit as x approaches c of square root of f of x, we take the limit as x approaches c of f of x, which is 4. Then we simply take the square root of that, it's 2. C, the limit as x approaches c of 3 times f of x, well, this is the constant multiple rule. So that's just 3 times the limit as x approaches c of f of x, which we know is 4. So that's 3 times 4, or 12. And d, limit as x approaches c of f of x raised to the third power. We're going to take the limit of the inside function, limit as x approaches c of f of x, that's 4. 4 to the 3 halves power. Now an easy way to do this kind of problem, remember that this, a rational exponent, is power over root. The easy way to do this is to first take the roots. So the square root of 4 is 2, then to the third power is 8. So you might take the root first and then raise it to the power. And that does it for this section of problems.